you guys made a number line. I mean, I'll start at 0, 10, 20, 30, 40, 50, 60, 70. You don't even have to label all of them. I'm just going to label a few. Okay. Then 2 goes kind of right here. 27 maybe here. 40, 55, 73. And then you're going to draw your lines. Right, so these ones should be a lot further away. This one not as big as that one, and that one's further away. Yeah?
If you separated them, like instead of like 10, did 20, would that skew them too much?
If you did,
like instead of like I did 0, 20.
yeah, no, that's fine. As long as your 20s are all even, then that's fine. That's the key part. If you can't go, I can't go. You can't do this. You can't go. Zero, 10, 20, right? That's no good. 30, 40, right? That's going to be trouble. Right? They should be roughly even. Okay. Good. So, did you guys have? No, you didn't. I think that's it. Oh, outliers. Yeah, outliers. Okay, so we talked about outliers once before. It's a number that's very, very far away from the other data values in a set. But there's an official definition of outlier. It's any value that is. So you guys remember that whole IQR thing? What's IQR again?
Interquartile range.
Interquartile range. It's the distance from what to what?
Q1 to Q3.
Q1 to Q3. So you take that distance, Q3 to Q1, you find out how far that is, and you take one and a half of those, you add it to your Q3, anything beyond that is an outlier. You take that amount, you subtract it from your Q1, anything beyond it that way is going to be an outlier. So that's kind of the definition. So I'll give you guys an example. Here's some data. Split into halves. So here's my Q1. Here's my Q2. Yeah? Now, that means that my IQR is what? Q3 minus Q1. What is that? Anyone? Yep, 10 minus, help me out guys, folks, 4, so it's 6. That's an IQR. But I want 1.5 IQRs. That's going to be 1.5 times 6, because 6 is my IQR. So it's going to be 9. Right? Think of it like this. An IQR costs $6. How much does 1.5 IQRs cost? $9. So is that a little bit better if you kind of put it in terms of money or something you're kind of more familiar with? So my IQR is 9. I'm going to find my Q1, and I'm going to subtract 9. So I'll get to -5. I'm going to take my Q3. I'm going to add an IQR. I'm going to add 9. So then I get to 19. Anything beyond 19 in this way, or beyond -5 in that way, is going to be an outlier. Do you have any outliers?
Yes.
Yeah. What's beyond 19?
20.
20. So 20 is an outlier. Does that make sense? Because I found an IQR, then I found 1.5 IQRs, and I added it to 10 to get 19. I subtracted from 4 to get -5. Those are kind of my boundaries for if you are beyond this, you are an outlier. Okay, so here 20 is an outlier. Here it is a little bit prettier. You guys have a problem at the bottom of your page. Here's a 5-number summary. We already gave it to you. It's right here. Everybody find an IQR. IQR equals. Tell me what that is. And then we're going to find 1.5 IQRs. Five-number summary. Everyone just find one IQR. Check with your neighbors. 30 seconds, check with your neighbors. I'm going to randomly call on someone in 30 seconds. So check in with your neighbors. What's an IQR? Francois? You got Omar over there as an island by himself. Oh, yeah.
It's all in there. I don't know.
So what's an IQR? It's Q3 minus Q1. Which one of these, how does my 5-number summary go? Look, it says it right here. Min, Q1, Q2, my midpoint, or my median, Q3 and my max. So 120 is my max. I don't want that. 42 is my Q2. I don't want that. 14 is my Q1, or my min. I don't want that. I want my Q3, 61, and my Q1, which is 23. Everybody find my interquartile range. Find it. Alberto, what'd you get?
3.
So it's Q1. What's my Q3? 61. I'm going to subtract what?
Your Q1.
My Q1. Francois, what's my Q1? 23. Everybody do that. If you need a calculator, I'm going to ask you in 15 seconds.
38.
38. Thank you. So my IQR is 38. One IQR is 38. I need to know what 1.5 IQRs are. Everybody check with your neighbors. I'm going to randomly call on somebody in 15 seconds. Also check across the way. You know, maybe.
I don't.
I want 1.5 IQRs. 1.5 IQRs.
From 1.5 IQ, the first boundary minus 34 and the positive probability 118. So
All right, how do you find 1.5 IQRs? You times by what? 1.5. Yeah. You want 1.5 of them? You multiply by. If I have $10 and someone says I want 1.5 of those, how much do they want? Well, they want $10 and half of $10. What's half of $10? 5. So they want $15, right? 1.5. Right? Is that making more sense? Okay. So I want 1.5 of 38. Which is 7. Okay? So that's my first part. Now I need to do what with those? You subtract it from Q1. and you, someone else?
Q3 and
You add it to Q3. So everybody find that. My boundary, my lower boundary, my lower limit, my lower limit for outliers. It's going to be Q1 minus what you just found. And my upper limit that'd be 2 IQRs. I don't want 2 IQRs. I want 1.5 IQRs. Okay, so Nathan, what'd you get?
I said no.
Oh no, what's my lower limit?
Oh, the lower limit, I got negative 34.
Okay. Rohan, did you get an upper limit? You get
Me?
upper? Yes.
oh I think it was wait, hold up. 115.
Sorry, can you take my Q3? What's my Q3? Look up, what's my Q3?
61.
And I'm gonna add, what?
57, so that's 118.
Yeah. Good. All right, good. So is 14 considered an outlier? No. It's within the range. Is that your only question?
No, he has 120.
Oh, is that 120?
Yes.
Yes. All right, everybody doing that part? All right, great. All right, put that one away. Now we're going to look at chapter 5. A random variable. Why am I reading? Michaela, go to read for me.
A random variable RV is a variable whose values are determined by chance. A discrete RV assumes that the finite number of values between 2 points can be counted. A continuous RV has infinite possible values between 2 points and comes from data that is measured.
Right? So similar, thank you. So similar concepts. If it's finite, if it's discrete, then any 2 values has the number. Sorry, the data can be counted. If it's continuous, then the values, the data are measured. It's random because it's all determined by chance. Here's an example of something by chance. Rolling a dice. If you roll a dice, what you get is totally random. What are the possibilities? What are the outcomes for a roll of dice? What could I possibly get?
6. 1 through 6.
1 through 6. Those are all the possibilities. That's my sample space. Right? My sample space is 1 through 6. So a discrete probability distribution is where you list all of your possible x's, your sample space. What you could possibly get. X is what you can get. Then you have the probability of x. The probability of x is the probability of each of these outcomes. Right? So the one that says probability of x, that's the one that darn well better be less than 1. between 0 and 1. Remember our second law? What is the first law? Probabilities have to be between 0 and 1. If you get a probability of 3, that's impossible. 300% chance of something, you cannot have that. You left out the out of, 3 out of something. Right? 3 out of 12 marbles, or whatever it is. So, remember the probability has to be between 0 and 1. What's the probability of rolling a 2? Not 1, 1 out of 6. Super important. That's why I'm taking extra 30 seconds to emphasize that. Okay. So, discrete probabilities, some basic things. All the probabilities, if you add them up, had better add up to 1 or 100%. And every probability has to be between 0 and 1. So, stuff you guys are kind of familiar with. You can also represent them graphically. So this is flipping a coin 6 times. If I flip a coin 6 times, how many heads could I get? 6 or 0 or anything in between, right? Yeah, 1, 2, 3. So the possible outcomes of flipping 6 coins and counting the heads is 0 through 6. So are you on board with that? Those are possible outcomes. Now, the probability of each of those outcomes, if I flip a coin 6 times, how many heads do I expect to get? 6. If I flip a coin 6 times, I should get 6 heads?
At least 3.
Yeah, you expect 3, half of them, right? So 3 is how many you expect, and that's the most likely, 31%. But I might get 2 heads or 4 heads, a little less likely. I could get 1 or 5, that's really quite unlikely. Or it's really unlikely to get 0 or 6. Possible, but super unlikely. You'll notice that when we graph them, so above is the probability distribution table. You see all the x's, all above, 0, 1, 2, 3, 4, 5, 6, the number of possible heads I get. So that's the thing that varies, right? The possible outcomes. And then the probabilities below that. I'm telling you that was going to happen, I guess. It must be 7 o'clock. And then, over here, we have our graph that shows the heights. And notice how these are very thin bars or lines that do not touch each other. These are discrete. Right? They're just a line straight up to whatever the probability is. So like a relative frequency graph, sort of. All right, so you guys have 2 questions. This one, and you also have this one here. So this one, you're going to state whether or not it could be a probability distribution, why or why not. And then this one, you're going to make your own probability distribution. So you're going to draw something like this. You have all your x's, all the possible outcomes, and then you're going to have the probability of each of those. So what could happen if a child plays? What could be the outcome? What's one outcome? The child plays, what could be the outcome? Computer. So on board? What's another outcome? Dress up. Right? So computer, what's probably the computer? Figure that out, put that in. And then you're also going to make a distribution. You're going to make a little graph over here. Right? Computer. And you're going to figure out, well, what's the probability and how high that line goes. All right, so we'll take a few minutes to do that. So for the graph, you need to go up to 0.45, right? So I would probably just do 0. You should start at 0, because otherwise it's a bad graph. You need to go to 45. I'd probably just go 0.10, 0.1, 0.2, 0.3, 0.4, 0.5. That's probably what I would do. And you're not really worried about it too much. Right. So, this first one, can the first one represent a probability distribution? Yes or no?
Yes.
Yes. Why? If you add them all up, you get 1. How about the next one?
No.
No. What's one reason why?
Because
Yeah, because you can't have a negative probability. Right? That's one problem. And does not add up to 1. Perfect. Good. Great. Now this one, let's see, what were the rest of these options? They were dress up, blocks, paint, and it is 0.27, 0.18, and 0.1. So then down below I have dress up, blocks, and paint. This one should go up to 4.5. This one goes up to 0.27. This one goes up to 0.18. And so something along those lines. Good?
Yeah.
It should not look like this. That's no good. Because these are discrete, they don't touch. Okay. Now, the mean. So the mean, another word for mean is expected value. They're the same thing. The mean or expected value for a probability distribution is the following. It's basically a weighted mean. Mu is equal to the sum of every x multiplied by its probability. In other words, every x value multiplied by its weight. So the probabilities are basically their weights. Here's the thing. If you take every probability or every x multiplied by its weight and divide by the sum of the weights, that's your mean. But what's the sum of my weights? What's the sum of the probabilities always going to be?
1.
1 or 100%. So you only need to divide by 1 because it's if you divide by 1, you get the same thing. So you don't have to worry about that part. So for example, I have a box. In this box are the numbers 1, 2, and 3. I draw a number, I put it back, I write it down. I draw another number, I write it down, put it back. I do this over and over again. On average, if I add up all those numbers and average them, what will I end up getting? Okay, think of it this way. You go to grandma's house. Every time you leave grandma's, she offers you 3 envelopes. Everyone look here. I need everyone's attention here, guys. I'm waiting. Okay, 3 envelopes. One envelope has $1 in it. One envelope has $2 in it. Another envelope has $3 in it. Every time you leave grandma's, you get to take an envelope with you. Next time she replaces again, $1, $2, $3. You don't know what it is. On average, how much money are you going to make going to grandma's? You just take 1 envelope each time you go. So you might get $1, you might make $2, you might make $3. On average, how much are you going to make going to grandma's?
2.
Well, you only get 1 envelope each time you come. So on average,
2.
how much? $2 on average. Like in other words, you go 3 times, you might get, you divide by 3. Right? In other words, typically, each time you go to grandma's, you'll make about $2 each time. Why is that? Because you might take $2, but every time you get $1, you're going to go another time you'll get $3. Right? They should average out to 2. So here it is. The official formula. Each one has a 1/3 chance. So $1 times 1/3 is 1/3. $2 times 1/3. 2/3. $3 times 1/3 is 1. If I add up these, I get 2. That's my expected value. Right? Each one of these kind of contributes 1/3 of its value to the total, because they're each 1/3 likely to happen. It's exactly like a weighted mean. Here's an example rolling a dice. You guys are doing this with me. With me. So here's my outcomes. This is the first one we saw, right, with all the possibilities 1 through 6 of rolling a dice, each with a 1/6 chance. So what's the mean number? If I roll the dice over and over and over again and average all the rolls, what would they average to? That's the question. So here, I'm going to take 1 multiplied by its probability. plus 2 multiplied by its probability, plus 3, you guys are doing this with me, yeah? 3 multiplied by its probability, plus 4 multiplied by its probability. Not have red and green yesterday, that's a problem. Oh well. Plus 5 multiplied by its probability, plus 6 multiplied by its probability. So that ends up being 1/6 plus 2/6 plus 3/6 plus 4/6 plus 5/6 plus 6/6. So altogether that is 5, 10, 15, 21/6, or 3 3/6, which is 3.5. So it means on average, you're going to roll a 3.5. Why is that? For every time you roll a 1, you'll roll a 6. 1 and 6 average to 3.5. For every 2, you'll roll a 5. 2 and 5 average to 3.5. For every 3, you'll roll a 4. 3 and 4 average to 3.5. Here it is a little prettier. You folks need to do the graph problems, problem number 3 on your worksheet. Here's the deal. Who can read? Isla, read to me.
Graph facts. A craft store has 25 assorted graph bags on sale for $3 each. 15 of the bags contain $3 worth of merchandise. 6 contain $2 worth of merchandise. 2 contain $5 worth of merchandise. 1 contains $10 and 1 contains $20 worth of merchandise. Is it worthwhile to buy a grab bag? Find the mean value of your profit or loss for this probability distribution.
Great. So what's happening? I'm going into the store and I'm buying a grab bag. What's the possible outcome? Hey guys, focus or it's going to be trouble for you guys. What's my possible outcome? One of my X's, those are my outcomes.
$3.
I could get $3 worth of stuff. What's another possible outcome if I get a bag? $2 worth of stuff. So those are my possible outcomes. Those are my X's. $3, $2, right? Those are your X's. What are the probabilities of each? Well, what's the probability that I get a $3 bag? 15 of them out of. Don't forget the out of. Not 1,500%. 15 out of 25. Okay, do it. We have 5 minutes left. Says it's time to go. Almost time to go. So $3, $2, $5. Don't forget, it's not $3. It's not 15. My probably is not 15. Don't forget the out of, right? That can't be 1,500%. If you're out of, or else you're gonna be in trouble. 15 out of 25. How many have $2? $2? 6 out of 25. $5? 2 out of 25. 1 out of 25. 1 out of 25. So then you're going to multiply 3 times 15 over 25 plus 2 times 6 over 25. Or you can change the decimals like Destiny did, which might be easier for folks. Just throw it onto your calculator. And what do you guys get?
97 out of 25.
$3.88. Right, so you make 88 cents on average, assuming they have stuff you like. All right, have a good, have a good long weekend. I will not see you guys till Tuesday. Oh, you're exempt. All right, so let me